Hello, chemistry. We are back with lesson 4. We're still on lesson 4. And we're going to talk about the next types of chemical reactions. This first one is single replacement. Single replacement. Okay, single replacement is where you replace this A, and it's going to go over here, and the B is going to go by itself. Okay, the ions switch places. They switch places. So let me find my notes, just a minute. Okay, so in single replacement, we're going to switch. Oh, here, I found it. We're going to switch places. We got an element plus a compound, and it yields an element plus a compound, but they're just going to switch. There's two kinds of single replacement. Okay, there's a cation or cationic, where metals switch with other metals or hydrogen. Of course, there always has to be an exception, right? So cationic, metals switch with other metals or hydrogen. So an example of that is going to be this. Oop, made that too small. Okay, where iron and copper are going to switch. Two metals. They're going to switch with each other, and now we're going to get iron chloride and then copper by itself. That's cationic, and the other one is anionic. Okay, this one is what you would think. Nonmetals switch with nonmetals. So here's an example of that. We've got fluorine plus NaCl, and that gives you NaF plus chlorine. So these two are switching. Okay, two nonmetals are switching. So those are the two different kinds of single replacement. So let's look at some examples of that. First of all, let's see, where do I want to start? We'll just start here in your notes where it says predicting products. Okay, just so you know that the cationic is when metals switch with metals, or hydrogen if hydrogen is there, or anionic where non-metals switch. All right, so let's look at the examples in your notes where it says single replacement reactions predicting products. Number 1, we've got zinc plus water. What is that going to equal? Zinc is a metal, and we've got hydrogen over here. So that's going to be cationic because it's a metal and hydrogen. So those are what are going to switch. So now we're going to have zinc and oxygen. What does zinc and oxygen look like? You'll have to look on here. And if you look on the back page of your polyatomic ion reference sheet, it says zinc always has a charge of +2. That's one that is back there. So zinc has +2. Oxygen has minus, it does? Oxygen has -2. So why did that do that? Okay, I think this is maybe wrong. Oxygen has -2. So this is going to equal ZNO plus hydrogen. And everything is balanced. I think. All right, let's look at number 2. Okay, we got Cl2 plus NaBr. So we got chlorine right here, and we got, is chlorine a metal or a non-metal? It's a non-metal, so that means this is going to change. Remember that the metals are the ones with plus charges, so those are the ones that are first. So since chlorine is a non-metal, you know that that is going to change with the bromine. So we're going to have NaCl, and if we look, you already know that NaCl is salt, because Na has a +1 and Cl has a -1. So that gives you NaCl, and then we're left with bromine, and bromine is a diatomic. So it is, it's got to have a 2. So then you have to balance this equation. We got 2 chlorine over here, so we got to put a 2 here. And now if we put a 2 here, we got 2 sodium, 2 sodium, 2 sodium, 2 bromine, 2 bromine, 2 chlorine, 2 chlorine. So everything is balanced, and we are coefficients are 1, 2, 2, 1. That's a mistake on there also. If we look at the next one, number 3, we got aluminum plus copper chloride. Okay, aluminum is it a metal or a non-metal? It's a metal. So that means it's going to switch with copper. So we're going to have aluminum and chloride. Aluminum's charge is what? +3. And chloride's charge is what? Chlorine. -1, right? -1. So that becomes AlCl3. Remember when we do this? And the one that's by itself is going to be copper, and it can just be plain old ordinary copper because it's not diatomic. So then we have to balance this equation. 1 aluminum, 1 aluminum, 1 copper, 1 copper. Uh-oh, we got 2 chlorines and 3 chlorines, which means we have to put a 3 here and a 2 here. So now we have 6 chlorines and 6 chlorines, but that gives us 3 coppers. So we got to put a 3, and that gives us 2 aluminum. So we got to put a 2, and our coefficients are 2, 3, 2, 3. Okay, and the last one, number 4 of single replacement, is CONO3 2 plus magnesium. And what is going to switch? What is CO? CO is cobalt. No, CO. Cobalt is a metal, and magnesium is a metal. So that means those two are going to change. So we got magnesium, and Grace, what is NO3? Is nitrate, right? Nitrate. Well, NO3. This is NO2. Right. NO3 is nitrate, and it has a charge of -1, and magnesium has a charge of +2. So when we do this, it becomes magnesium nitrate, like that. And then we just got our cobalt by itself. Now we got a balance. Okay, 1 cobalt, 1 cobalt. 2, look at this. This whole thing is nitrate, and this whole thing is nitrate, and there's 2 of them. So you wouldn't even have to think of each one separately if you didn't want to, because they're already balanced, and magnesium is already balanced. So it's already balanced with coefficients of 1, 1, 1, 1. Okay, that's single replacement. You've got to look if the metals are going to switch with each other or if non-metals are switching with each other. Okay, the non-metals, remember, the non-metals are the ones that have the negative charges. So they would be the second ones in a compound. The metals have positive charges, so they would be the first element in a compound. So that's how you know which ones are going to switch. That help a little bit? Okay, let's look at double replacement. Okay, in double replacement, we got 2 compounds, and we're going to make 2 new compounds. Okay, compound plus compound yields a compound plus a compound. You have to remember that the first one in a compound is the plus charge, and the second one is the negative charge. So that's why over here it looks like AD, and we didn't change it to like AC, because A and C are both plus charges. So the A has to go with the other negative, and the C has to go with the other, because since C is positive, it has to go with the other negative. So that's how you tell what's going to switch with each other. Okay, so let's look at some examples. 1 through 4 examples on your notes for double replacement. Okay, number 1, we've got BaCl2 plus Na3PO4. So now Ba barium has to go with PO4, which is, what is PO4? Phosphate. And sodium has to go with chlorine. So let's look at the first one. Barium. Grace, what is the charge of Ba? Maybe a plus. Okay, is +2. And phosphate has a charge of PO4 -3. So when we switch these, that becomes Ba3PO4 2. And then we've got sodium and chlorine, and those are both plus and -1, right? Yep, because we know that that is salt, NaCl. Okay, that's how you decide what goes there. Now we got to balance this. We got 1 barium, we got 3 over here. Okay, we got so if I put a 3 right here, it's kind of trial and error. Now our bariums are balanced, and we've got 6 chlorine. So that means, let me erase this so that I have space to write a 6 in there. So now we have 6 chlorine. So the Ba and the Cl's are all balanced. But now we've got 6 sodium over here. So we only have 3 of them here. So I'm going to have to put a 2 there. And that gives me 2 phosphate, which I got 2 phosphorus, and 2, or, well, this whole thing is phosphate, but just the P is phosphorus. And I got 8 oxygen, and I got 8 oxygen. So everything is balanced right here, and my coefficients are 3, 2, 1, 6. Okay, and everything is balanced. And you can see by looking at these coefficients that I couldn't reduce that by anything. Nothing goes into all those numbers. All right, let's look at the next one. Number 2, we've got KCl. plus H2SO4. All right, the potassium now has to go with SO4. What is SO4? Sulfate, and sulfate has a charge of -2, and potassium has a charge of +1. So when we do that, we end up with K2SO4. And now our hydrogen is going with our Cl. Hydrogen or chlorine, hydrogen has a charge of +1 and chlorine has a charge of -1. So that becomes HCl. Now we've got to balance it. 1 potassium, 2 potassiums, let's put a 2 there. Now that gives us 2 chlorines. We only have 1 chlorine, so we'll have to put a 2 there. Now that gives us 2 hydrogen. We already have 2 hydrogen, 1s, 1s, 4 O's, 4 O's. Everything is balanced, and we've got 2, 1, 1, 2 as our coefficients. Okay, let's look at number 3. Number 3 is Ag2SO4 plus NH4Cl. All right, this one is a little bit more complicated. We've got Ag, which is going to go with Cl. And Ag is silver, right? And if you look on the back of your polyatomic ion, it says silver has a charge of +1 and chlorine has a charge of -1. So that just becomes AgCl. And this whole thing together is ammonium, which is the one polyatomic cation that we have that has a positive charge. That's on your chart. That has a charge of +1, and that's going to go with SO4, which is sulfate, which has a -2. So when that goes like that, we've got NH4 2SO4. That's where all those things come from. Now we got to balance it. Okay, 2 silvers, 1 silver. So let's put a 2 here. Now we have 2 silvers and 2 silvers. Now that gave us 2 chlorines here. So we need to put a 2 here so that we have 2 chlorines. Now we have 2 ammoniums. And we have 2 ammoniums over here. We have 1 SO4 and we have 1 SO4. So everything is balanced and our coefficients are 1, 2, 2, 1. Okay, one more of the double replacement. Number 4. We've got Ki plus PbNO3 2. Okay, so let's see what's going to happen. K is potassium, and it's going to have to now go with NO3, which is nitrate. Nitrate has a -1. That's from your polyatomic ion chart. Potassium K has a charge of +1. So those cancel each other, so that just becomes KNO3. And then we've got lead and iodine. Lead has a charge of what? Oh, lead we don't know has a charge. Lead has more than 1 charge. So we're going to have to look at this to see which kind of lead it is. Since we know that NO3 has a charge of -1 from here, that means that our lead must have had a charge of +2. And iodine has a charge of what? -1. So when we go like this, we get PBI. So you can see we're putting, oh, I2, I'm sorry. So we're putting everything together that we've learned from all the other chapters. You can't forget all that other stuff that we've learned. So now we've got to balance this. Okay, 1 potassium, 1 potassium. 1 iodine, oh, we got 2 iodines over here. So I'm gonna put a 2 here, which gave me 2 potassium. So I'm gonna put a 2 here, which gave me 2 nitrates, which we already have 2, and we have 1 PB and 1 PB. So everything is balanced and our coefficients are 2, 1, 2, 1. Okay, that's double replacement. Now let's go on to the very last kind that is a little bit easier, I think, and that is combustion. Okay, a combustion reaction, it's where substances react with oxygen, releasing a large amount of energy. So if you look on your notes, it's going to be a hydrocarbon plus oxygen, and it always yields carbon dioxide and water. That's always going to be the ending. So let's look at some of the where it says try it on your own. Okay, we got C3H8 plus oxygen. Okay, it's always a hydrocarbon and oxygen, so that's what we got here, and it always ends up with carbon dioxide and water. This is always what's going to be on this side. So now all you have to do is balance. Okay, we got 3 carbons, 1 carbon. So let's put a 3 here. We got 8 hydrogen right here, and we only got 2 hydrogen over here. So that means we're going to have to put a 4 there. So we have 8 hydrogen now. So the hydrogens and the carbons are all balanced right now. We've got 2 oxygen here. Over on this side, we have 6 oxygen there and 4 oxygen here, which is 10 oxygen altogether. So over here, we need to have 10 oxygen. We have 2, so we're going to have to put a 5 in front of it. Okay. And the coefficients will be 1, 5, 3, 4. All right, let's look at the next one. C2H6 plus oxygen gives us CO2 plus H2O. That's the easy part because it's always going to be the ending. Now all you have to do is balance. 2 carbons over here, only 1 here. We got 6 hydrogen, we only have 2 hydrogen. If we started by putting a 2 right here, so our carbons are all set, then our oxygen, we only have 2 oxygen over here. Over on this side, we have 4 oxygen plus 1 oxygen, which gives us 5. Since this is an even number over here, we're never going to get an odd number. So somehow we have to make this over here even. But let's look at our hydrogens. We've got 6 hydrogens here. If we put a 3 here, so we have 6 hydrogens. Now we have 4, 5, 6. Now we have 7 oxygens, but that's not going to help us because we need to have it be even. So we're going to have to try again. How about if I put a 2 here? I'm going to erase these because that didn't work. If I put a 2 here, that gives me 4 carbon. So that I'll put a 4 here, which will give me 4 carbon. Just a minute, this is an H2O. Sorry about that. So now we got 4, and we've got 2 times 6, we've got 12 hydrogen. So over here, we would have to put a 6. So we have 12 hydrogen. Now let's count our oxygens. Over on this side, 4 times 2 is 8, and 6, and 8 and 6 is what? 14. So we have 14 oxygens over here, Now we have an even number, so we can put a 7 there, so we have 14 oxygens, and our coefficients are 2, 7, 4, 6. There's no numbers that go into all of those, so we're good, and we're at the end. Okay, it's a trial and error to decide how you balance equations like this. So one more, C7H16 plus O2, those are some big numbers, and we got CO2 and H2O. Remember that that's always going to be our ending. So let's see what we're going to do. We got 7 carbons, so let's start with a 7 there. We got 16 hydrogens, so let's start with an 8 there. Our carbons and our hydrogens are all balanced right now. Over on this side, we have 7 times 2, 14 plus 8 oxygens, which is 22 oxygens on this side. So if we put an 11 right there, that gives us 22 oxygens on this side, and our coefficients are 1, 11, 7, and 8. And that's good. We can't reduce those at all. So this is a good balanced equation. All right, that is combustion. So let's go back to your homework page and look at the back side so we can do some of these together. Let's start with number 17. Number 17, it says balance each equation and identify the type of reaction. So let's look at it. Al plus Cu Cl2. Oh, that was bad. Let me try that again. I wasn't watching. And that gives us AlCl2 plus Cu. So what kind of reaction is that? The Al and the Cu are changing places. So this is single replacement. Only 2 things changed. If there were, well, there's only one switch. If there were 2 switches, then it would be doubled. So now you have to balance. 1 aluminum, 2 chloride, 2 chloride, 1 copper. It's all balanced, and our coefficients are 1, 1, 1, 1. Okay, let's look at number 19. Number 19 is Fe plus S8. And that gives us FeS. What kind of equation is that? Or what kind of reaction is that? That is synthesis. 2 elements, 1 compound. So that's synthesis. So let's go ahead and balance it. Fe is all balanced, but look, we got 8 S's here, so that means we're going to have to put 8 there, which means now we're going to have to put an 8 here, and our coefficients would be 8, 1, 8. Okay, now let's look at, that's how you do 17 through 22. So I want you to finish those. They're giving you all the equations. You don't have to come up with what the answers, what the products are. You just basically have to balance it and say what kind it is. Now let's look at number 23. Okay, 23 is different. It says complete and balance the equations for the following single replacement reactions and label it as cationic or anionic. You're going to decide if it's cationic or anionic depending on if there's metals or nonmetals that are going to switch places. Okay, single replacement. So that means this is going to have to switch with something over here on this side. So Zn is zinc, and zinc is a metal. So that means this is cationic because metals are going to switch. So that means now the metals have a positive charge. So zinc has a charge of +2, and it's going to go with NO3, and NO3 is nitrate, which has a -1. So that's going to become ZnNO3 2. This is number 23. And then our lead is all by itself. That's a single replacement. Okay, and we knew because zinc here is a metal and it has a positive charge, we knew it was going to change places with this one right here, the one that has a positive charge. Now you have to go ahead and make sure that it's balanced, and it is. There's one zinc, one PB, one PB, one nitrate, everything's balanced. Our coefficients are just 1, 1, 1, 1. And it is a cationic because metals were changing places. That was number 23. Good. Number 23. Now let's look at number 26. Okay. We've got Al plus NiSO4. Okay. Al is what? Aluminum. Is aluminum a metal or a non-metal? Metal. Since aluminum is a metal, that tells you that this is cationic. Okay, so aluminum has a plus charge. It's going to change places with Ni, which is nickel. So we've got aluminum has a charge of +1, +3. That was so wrong. And SO4 is sulfate, and it has a -2. So when we do this, we get Al2SO4 3 plus nickel there at the end. Okay, this is number 26. And now you got to balance. So we got 1 aluminum, we got 2 aluminum. So let's put a 2 here. We've got 1 nickel, but we got 3 of the SO4s over here. So we'd have to put a 3 here, which means now we have 3 nickels. So we can put a 3 there. And everything is balanced, and our coefficients are 2, 3, 1, 3. And it is a cationic because metals were switching with metals. Okay, I want you to finish 23 through 27 on your own. Those are single replacement. You have to decide if the first element is a metal or a non-metal to know which one it's going to switch places with. And that tells you whether it's cationic or anionic. Now let's look at the next section, 28 through 32. 28 says, complete and balance the following double replacement reactions. So now we're going to switch 2 things. MgCl2 and this is from the other lesson, plus AgNO3. So Mg, I'll use red for plus. Okay, Mg has a plus and Ag has a plus, and Cl is negative and NO3 is negative. So now we're going to put Mg with a new negative, which is going to be NO3. So the charge for Mg for magnesium is +2, and NO3 is nitrate, which is -1. So when we go like this, that becomes MgNO3 2. And then we're going to put our other positive, which is silver, and Cl. Silver, if you look on the back of your polyatomic ion sheet, has a charge of +1, and chlorine has a charge of -1. So that those, when we do that, it just becomes AgCl. So now we got a balance. Okay, we got 1 Mg, 1 Mg, 1 Ag, 1 Ag. Oh, we got 2 Cl's and only 1. So we better put a 2 right here, which gives us 2 silvers. So we're going to have to put a 2 right here. And now we got 2 silvers, 2 silvers, 2 chlorines, 2 chlorines, 2 nitrates, 2 nitrates. So everything's balanced. And our coefficients are 1, 2, 1, 2. Okay, that is number 28. Number 28. Let's look at number 31. We're going to do another one of these. Number 31. Okay, oh, another silver. We got silver nitrate. And sodium sulfide. Okay, silver's plus, and so it's going to have to go with sulfur, which is negative. So we're going to have silver and sulfur. Silver has a +1, and sulfur has what? -2. So they go like that, and that becomes Ag2S. And we've got sodium and nitrate. Sodium has a +1. Oh my word. And nitrate has a -1. So that becomes NaNO3. Just like that. So now we've got to balance it. 1 sulfur, 2 sulfurs. So we got, I mean, not sulfurs, I'm sorry. 1 silver, 2 silvers. So we got to put a 2 right there. That gives us 2 nitrates. We only have 1 nitrate, so we got to put a 2 over here. That gives us 2 sodiums. We got 2 sodiums, and the sulfur's all set. So it's all balanced with 2, 1, 1, 2 for our coefficients. That's number 31. So you have 3 more like that you need to do yourself. I've done 2 of the 5. Okay, let's look at number 33. Doing some of each kind. Number 33, complete and balance the following combustion reactions. I think these are the easiest because we know what the answer is. The answer is always CO2 plus H2O. That's always what the product is. All you have to do is balance. 3 carbons, only 1. So let's put a 3 here. That gives, we got 8 hydrogen, only 2. So let's put a 4. That gives us 6 oxygen there and 4 there, which gives us 10 oxygen. So we got to put a 5 there. So we have 10 oxygen on that side, and our coefficients are 1, 5, 3, 4. And so everything's balanced. Okay, that kind I think is the easiest. You can, there's only 2 more of those. You can go ahead and do that. And the very end, 36 through 40, you have to decide what kind of reaction it is and then decide on the answer. So let's look at 36. Okay, we got zinc plus H2CO, H2CO3. What is that going to be, do you think? When we have an element and a compound, that's probably going to be a single replacement. Okay, and since zinc is a metal, that means it's going to change places with hydrogen, because remember that that was one of the exceptions. Metals change places with metals or hydrogen. So now we're going to have zinc and CO3. So zinc has a charge of +2, and CO3 has a charge of -2. So that becomes ZnCO3. And then we've got hydrogen out there by itself. And hydrogen always has a 2 because it's diatomic. Don't forget that. So then you need to make sure that it's all balanced. And it actually is all balanced already. 1 zinc, 2 hydrogen, and 1C, 1C, 3O, 3O. So everything's balanced and our coefficients are just 1, 1, 1, 1. Okay, 36 is that. I'm going to cross off number 37. We're just not going to do number 37. Okay, you may all cross off number 37 so you don't have to do it. Now we're going to just look at 38, 39, and 40 and decide what kind of equations these are. 38 is going to be decomposition. 39 is going to be synthesis. And 40 is going to be combustion. Okay, so I want you to finish those and see if you can do the rest of that homework. And in the next video, I'll talk about lesson 5. And there's actually a reference sheet that I forgot to give you. So I will attach the reference sheet to the assignment in Google Classroom so that you can know which things are soluble in water. That's what that sheet is going to help you. So look for that also.